Hi there everyone. In this video lecture we shall dive into the definitions that build up set theory. So the first definition of set, a well-defined collection of objects is called a set. Okay. So how do you denote a set? They are generally denoted by capital letter A, B, C, etc. Okay. And the elements of set are the members of the set. Okay. So how do you write a set mathematically? There are two ways of writing a set. Listing method. In this method, if you take an example, you write all the elements of the set, okay, if possible. If the set is very small, like over here, A is a set of English vowels. So the set in English vowels is A, E, I, O, U. Then how do you write that set? Capital A equal to curly brackets A, E, I, O, U, separate each element by comma. Okay. Now let us take another example. B is a set of multiples of 3. So the set, if you try to write, that would be B equals to 3, 6, 9, 12 and so on. Okay. So I'm taken positive multiples over here. So let us see. So now this set is infinite. 3, 6, 9, 12, 15, 18 and you go on and go on. You can go on up to infinite numbers. So you just put dot dot after mentioning few elements and complete the bracket. So this is the listing method in which you try to write all the elements of the set. If the set is finite, you try to write the elements. Okay. If the set is infinite, you mention few elements and then you can put dot dot and get it done. Okay. Now this is very cumbersome or tedious at times to write all the elements. So in mathematics, we are interested in writing the compact form large number of time. So the compact way of writing this is a set builder method. Okay. In this method, how do you write this set A? So it is written in this way. So how do you write it is, give the name A again, capital A. For the elements A, E, I, O, U, you declare a general variable X. Okay. Now this vertical line that you see is known as such that. Okay. So X is a vowel in English language. So now those who know English language, they know that the vowels are A, E, I, O, U. So that is done. So you don't have to think so much. You just remember X, it is A, E, I, O, U. X is such that X is a vowel in English language. You don't have to worry about the entire set. You just have to say this much. So let us see how to write this infinite set in terms of mathematical notation. It would be B. You declare a variable y, okay, such that now y is equals to 3n, where n is a natural number. Now this is very technically written in mathematics because n is natural number. N being natural number, it is going to obviously start with 1, then 2, 3, 4, 5 all will come into the picture. So when n is 1, the first element y equals to 3 into 1 is 3. So that is what is available. Okay. So when n is equals to 2, 3 into 2 is 6. So that is the second element. When n is 3, it will be 9. 4, it will give you 12. For 5, it will give you 15 and so on. So this kind of technical y equal to 3x or 3n is defining my entire set B, which is listed over here. So this is correct way of defining the set in the set builder method. Now how I have done this, there is a way to write any set in a set builder method. The first, I'm giving you the entire procedure here. Give the name to the set. Okay. Declare the variable. Okay. It may be a y, x, whatever it may be. Okay. You give some name to that variable. Okay, along with that, there is some variable feature. Maybe y is over here. If you see 3, 6, 9, 12, they all are positive integers. Okay, so you might need that. You will soon see what is variable feature. Okay, now such that if you write variable feature over here in the first part, you need not write it second time. Okay, if you don't write in the first part over here, you write in the second part. Okay, you write the property of the elements of the set. So y equal to 3n is the property. Okay, and what is the condition on n? Condition is n should be natural number. So that is the condition. So this is general format or a layout of a set builder method in general. Okay, so you can understand it is the variable such that the property or the conditions are given of the about whatever the elements are in the set. So this is how in the set builder method you write any set. Okay, now I am giving you general standard notations in the world of mathematics that are used for the sets which are very common in mathematics. That is, set of natural number 1 2 3 4 5 is now onwards going to be denoted by this kind of scripted n. Okay, you can say outlined n. Okay, then set of integers, okay, is going to be denoted by this kind of z, outlined z. And the set of rational number, now you see there, this is the set builder way of talking about the set of rational number. The elements of the set are of the form p upon q such that p comma q belong to z. So this is the feature of p and q, and q not equal to 0 is the condition. Now the set of real numbers will be denoted by this kind of r. Set of irrational numbers will be denoted by r minus q. Okay, and the set of complex numbers will be denoted by this kind of outlined c. Okay, now if you observe for set of complex numbers also, we have the set builder notation over here. A plus bi is the form of the elements which are there. Now what are the features, or what kind of elements you have a plus bi? So a and b are real, and I is nothing but square root of minus 1. So that is the kind of the feature of the variables in it, right? So that is what you mention over there. That's it. So you are done with the standard notations that I will be using throughout, and these are standard all throughout in the world of mathematics. You can refer any standard mathematics book, you will get these notations over there. Okay, now one more important notion I am going to give you. Intervals that you have seen are also sets, real intervals. Okay, so if you see, this is the closed interval a comma b. In that set builder notation, if you try to write, it is nothing but x belonging to R such that a is less equal x less equal b. So this is the condition on x. Okay, so that is how the notation is built up. So this is the open interval, this is semi-open closed intervals, you can call them. Okay, so these are the intervals, and you can go through all of them. So for this video lecture, I am giving you only this much because I have introduced lot of new notations. The entire set theory chapter or the video lecture series will be giving you a lot of new notations in the set theory. So be comfortable, get used to all these notations so far. Then we will see all other new concepts in the next video lecture. Till then, thank you.